Hello, ladies and gentlemen. This is Mr. Green. This is my pre-cal class for uh, January 8th. I realize our class is at 2 o'clock, and I'm recording this much earlier in the day. I am going to be out this afternoon, so I wanted to give you this recording so that you could have it. Where are we in our pre-cal class? Well, right at the moment where I see us at by looking at the course is we should be looking at doing 5.6 practice and discussion right at the moment today. Tomorrow there's a Unit 5. It says Texas assignment. You'll find that up here in the doc sharing area of the course. If you go to doc sharing, there's the Unit 5 Texas assignment. It's all extra credit. So you do that assignment and you're going to get some extra credit. So it's really worth your while doing some of those things. Okay. Other than that, on Friday you're supposed to be taking the Unit 5 Part 1 and Part 2 tests. So I wanted to make certain I did a review of Unit 5's material and talk a little bit about what we're doing in Unit 5. Well, one of the things that we're doing in Unit 5 is conics. Conics are curves of one shape or another. We took that cone and we sliced the cone up and we can see that we get circles and ellipses and parabolas and hyperbolas. And that's what we're looking at and being able to tell them apart and where we use them and things like that. So, looking at this first question, it says, which conic section does this equation describe? Well, I'm seeing equal sign. I'm seeing the fact that I've got x's squared and y's squared and a number out here at the end that's not a 1. So this one is going to be a circle. Okay, that is just the format for a circle. So that's real easy to look at those formats and be able to tell them apart. This one, I can see fractions. Excuse me, fractions. My denominators are not the same in this situation. I got 25 and 36. But when you subtract them, they're equal to 1. Well, the fractions, the fact that they're squared on top, tells me that this is going to be a hyperbola. Okay? The fact that you're subtracting them tells me that it's the hyperbola. That's what you have to be looking for. If I were to be adding them like I am in this question right here, see how they're being added? Still, unlike denominators, still equal to 1, still squared numerators up here at the top, then this one would be a ellipse. Okay? Ellipses and hyperbolas are the ones that use the fractions. Okay? That's the way I look at it. Ellipses and hyperbolas are the ones that use the fractions. They have unlike denominators, and you just go from there. Okay, this one, if I'm looking at this, I see the x's are squared, the y's are not. This is going to be a parabola. That's all you have to do to identify these. It really is simple once you start getting the hang of what the formats look like. Okay, this one, not as quite as obvious, is it? Because they've written it in standard form. And so what you have to be looking for when you're in standard form to do this correctly is get my cheat sheet out here so that I'm looking at it correctly. If I'm looking at standard form, if A and C are equal, these are both ones, then possibly you have a circle. Okay? If A and C are equal but both are not equal to 0, well, they're not 0, so it's not a parabola. Okay? If A times C is greater than 0, could be an ellipse. Well, circles are just specialized ellipse, so it could be that. It's not a hyperbola. I think what you're looking at here is a circle. Okay? Let's move on, see what else we come up with here. Okay? I see fractions. I see unlike denominators equal to 1 being added together. That tells me, what do I have? I have an ellipse. Okay? If I'm looking at an ellipse, it says they want to identify the vertices that lie on the major axis. Major axis is going to be the one that has the bigger number here. So 49 is the bigger denominator, and so my major axis is going to be on the x side. Okay? And so what am I looking at? Well, my length of my major axis is going to be the square root of this, which is 7, and it's going to be 2 times that. So my length is going to be 14 units long. And it's the x value that's going to change. So looking at where my center is located at, it's located at it's located at 2, -5, and that's going to be 14 units long, or 7 in both directions. So since it's at it's at 2, one of the places that the vertex is going to be at is going to be at 9, -5, and the other one is going to be located at -5, -5. That'd be this one right here. And how did I get that? Well, the thing I'm looking at here, and I want to make certain I'm being clear about this so that you understand it. This right here, this 49 down here, now let me highlight it. The 49 down there is telling me that it is the major axis. Why is it major? Because it's the bigger number. The denominator with the bigger number tells me the x-axis is going to be the major axis, the bigger axis. Okay? I took the square root of 49. That's 7. That means 7 in both directions from the center. Well, the center was located at 2, so I put 7 plus 2 gave me 9, and 2 minus 7 gave me the -5. The y coordinate is at -5, so I was looking for 9, -5, and -5, -5. That's how I found that vertex. Now, I had, in my last class, Connect, if you go back to that, I had given everyone a cheat sheet that I used to help me identify some of these things, the vertexes and the foci and things like that. So you ought to go get that cheat sheet and use it. I don't think I'm going to be able to send one out with this MP4 listing recording that I'm making here. Okay, so this one we're looking for the foci of this down here. Well, let's see here. Unequal denominators, squared terms in the numerators being added together. Once again, I'm looking at an ellipse. Okay, so the foci are located on an ellipse. Okay, what you have to do there is you have to find C. What's C? Well, this 49, this major axis, is the A term. The minor axis, the 36, would be the B term, and you're looking at A squared plus B squared. Oh, well, 49 plus 36, that's 70, 85. And so you take the square root of 85, and that's what C is. That's the C that we're missing there. Okay? So, let's see here if I can get in here and type this. Not there. Okay. So, C is going to be C squared is going to be equal to 49 plus 36. And so C equals square root of 85. Okay? Well, what's the square root of 85? Let's see here if I can do this quickly in my head. Um, okay. Well, I'm looking at these answers down here, and I'm seeing square roots of 5 and square roots of 13. Wonder why I'm not getting what I'm thinking I should be getting. Did I add that right? 49 plus 36 is 85. Okay. Okay. So, C is at the square root of that. So where are my foci located at then? So my foci are located at H, comma, K plus and minus C. Let's see here. Which is the major axis here? X is the major axis, horizontal major axis. So it's H plus or minus C. So it's going to be located at H plus or minus H plus C, comma, K, and at H minus C, comma, K. That's where my foci are going to be located at. Okay? So if I'm saying that C is the square root of 85, then my, uh, let's see here, we could tell already it's not going to be the first two answers here because they're adding on to the k. See how this is on the k term over here? So it's not going to be those two terms. It has to be one of these two right here. Okay? My y value is at -5. My x value is at 2. So it's got to be one of these two. And so we'd be looking at plus the square root of 7 and 6. I don't know why that's not working out like I think it should. Oh, I know what I'm doing wrong. Uh, Helps when you have a cold and you don't feel good. It's supposed to be a squared is equal to b squared plus c squared. Okay? Not c squared is equal to a squared plus b squared. So I'm going to be doing that, minusing 36. Come on, Charles, you should have known that. Okay? So 49 minus 36. Clear. 49 minus 36 is 13. And so we get the square root of 13 is what c is equal to. Okay? I just was trying to work a little fast there and it caught me off guard. Okay, so what we're looking at is 2 plus or minus the square root of 13. Okay? Hopefully I didn't confuse you all too much there. What I'm looking for is this is a, this is b, and so it's a squared is equal to b squared plus c squared. Okay, in this one we're looking for the vertex again. I see, unlike denominators, equal to 1, numerators are squared. See a minus sign. This is a hyperbola. Okay? So if I'm looking for the vertexes of a hyperbola, the vertexes of a hyperbola are located at, um, let's see, which one is the major axis? The x's are the major axis, so it's a horizontal. So I'm looking at h plus a, comma, k, and h minus a, comma, k. That's where the vertexes are going to be located. Okay? Well, I can see that my k is a -2. So I can eliminate a couple of answers real quickly. That one won't work, and that one won't work because my k is a -2, and I can see that already. Okay? So it's going to be one of these. Once again, a squared plus b squared equals c squared. Nope. A squared plus b squared equals c squared. Yes, that's what it is in a hyperbola. Okay? And my a and b are going to be my the numbers at the bottom. So 36 plus 25. Okay? C squared equals, whoops, I don't even need c in this case. A is going to be the 36. A squared is equal to 36, so a is equal to 6. So what would I be looking at here? Well, h is equal to 3. So 3 plus 6 is a 9. And 3 minus 6 would be a -3. So I'd be looking at -3, -2, and 9, -2. So it would be that answer right there. Can you see how I found the values that I was looking at? And yes, I have to look at my cheat sheet to find these answers. Not an easy trick to do. Okay, once again, hyperbola, y, unequal denominators, squared terms in the x and the y, and it's got a minus. So it's a hyperbola. We're looking for the foci. Okay? Okay. My x is my major axis, so it's a horizontal. And what I would be looking at for foci here would be h plus and minus c, comma k. So H plus C, comma K, and H minus C, comma K. Well, my K value in this situation is at uh, -2. A is equal to 6. B is equal to 5. And so I've got to find C. I'm going to take 36 plus 25 and get 61. And the square root of 61. Oh, that's what's on there, square root of 61. So we'll use that one, okay? And so C equals square root of 61. And so where's my value here? Well, H is equal to 3. So my foci are going to be located at 3 plus square root 61, comma, -2, and 3 minus square root 61, comma, -2. Right there. Hmm. Looks like that answer is exactly the same, isn't it? Doesn't matter which one you pick there then. Both of those are identically the same. I don't see any difference between them. Okay? I'm sure that was a typo in their part. They didn't mean to put both answers identically the same. Okay, number 18. Which direction does the graph of this equation below open? Well, I want to look at this and see what I'm looking at. I've got an x term that's squared and a y term that's not. Well, that means that I'm looking at a parabola, because parabolas are the only ones that have only one term squared and the other one not squared. Okay? So I'm looking at a parabola. Looking at this parabola, the value in front of the x term here is a positive 1. Being a positive 1, that tells me that it's going to be a positive number. That means it's going to open up. Remember, that term in front of the x is the one that determines whether it's a rainbow or a hook 'em horns. Positive numbers, it opens up. Negative numbers, it opens down. And that's the last one I've got on my review list here. I hope this review helped a little bit, and that's the type of questions you'd be looking at when you're looking at the test that you'd be taking for this unit. I am going to encourage you to get the conics cheat sheet, or what I called it was the conics sections formulas, and use those, because you should be able to use those formulas when you're looking at conics. There, I will look and see if it's not in. I could look right now. I thought I put it in the doc sharing. Let's see if it's out here. Nope, but I will put it out there today. It will be there for you, and you can use that in your when you're taking the test. Hopefully this helps. If you have any questions, feel free to come to the Thursday or Friday um, TOGA session, and I'll try to help you with them, those questions at this time. Thank you very much. Talk to you later.